Hi, welcome once again this beautiful section. We are going to discuss today about Harris data structure. Harris data structure in situations where we handle small number of elements, we can specify separate variables. Okay, we can handle small number of elements and you can specify a separate variables for each element. In case when we have to deal with a large amount of similar data elements, we can have an organized collection called an array. Okay, for a large amount of elements, we can use for array data structure. So that is how we are the technique is used here. The arrays are used to handle a large number of elements which are a similar data type, similar elements. Okay, so such data we call it as a array data. Okay, now we have two types of arrays. We are linear array and heterogeneous array. Okay, linear array means a similar type of a list of finite number of n homogeneous data elements. Okay, such that elements of array are referenced separately by index set consisting of n consecutive numbers. What do you mean by? So homogeneous data. Homo means similar. A similar data is stored in an array. Okay, so the significance of using arrays, when you have a big size of data of similar elements, that is called homogeneous data, you can store in a array data form or a data structure. If it are small things, you can store in a variables. Okay, that's why arrays data structures are very important. This is the first thing you need to understand. And how you declare array? In C language, you see that you declare array integer a of open bracket square bracket, say specify number of elements, size of the number of elements, a of 10 for example. So a of 10 semicolon. That is how you initialize or declare the variables. Size of the array a of 10. That means I have 10 elements you can store in a size of array A. A is the name of the array. You can give the number of students. Name is equal to name bracket, you can give 10. That means you can insert 10 names. Okay, that is how arrays are declared, and arrays are subscripted. Arrays are denoted by a subscript. Okay, for example, name of 10 elements were stored, so I can individual element, that is called subscript. Individual subscript can be denoted by subscript. I can call name 1, name 2, name 3, name n. Here the n is a 10. If I've taken a largest size of the element, n is 10, then it's called n is equal to 10 elements I can store in a given array. Okay, so first we need to understand what is array. Array is nothing but a collection of similar elements, a storing of similar elements in a given structure called array structure. Homogeneous, we call it homogeneous structures. Array. How each element is denoted? Each element is denoted by subscript. We call it a subscript notation. Okay, each element of array A may be denoted by the subscript notation, A1, A2, A3, AN, like that. And second thing you must know is how they are represented. Array is represented in a column format or in a linear format, one column or one row. Okay, we are dealing with a single dimensional array. We can represent a single dimensional array in a one column or one row, right? Representation of the linear array in memory. That is how you represent memory. You represent the array in a memory in a column format or a, excuse me, in a linear format. Okay. Now traversing a linear arrays. These operations and data structures. About when you talk about the operations on arrays, we have traversing one such operations. Traversing means we need to visit each element, visiting each element for what purpose? For doing some operations purpose, some search. It may be a visiting for searching for an element, visiting for inserting element, or visiting to search for an element, so on and so forth. Okay, so traversing has got its own purpose. uh, Maybe list to print out the numbers. So for that purpose, the traversing is one such operation is performed on the strings. So we need to define size of the array, and include a loop, and you construct the loop from lower bound to upper bound. Then under the loop, inside the loop, you perform what operations you want. It may be insert, maybe a print out each element in the array, or it may do whatever you want. Okay, such operations can be performed on a linear arrays. Okay, traversing is such an element. Similarly, insertion also you can do it. Insertion of the arrays, and you can specify. You can construct the loop and specify the location where you want to insert it, and then insert that particular element you want. Okay, for this and all we have algorithms and programs. We can use great examples. You can illustrate. Of course, in this video, you can't show that all those things. Just you need to keep the concept. Need to understand the concept. We can implement in your computer. About it may be traversing, it may be insertion. Arrays can be implemented using C language. So you can write algorithm. We can perform operations on arrays. Okay, that is on linear insertion operations. Similarly, you can do it deletions also. So deletion also. So here also same thing. You take a set of elements uh, and where to delete. Find out the location where to delete. Then delete that particular element. Okay, that is can be done using a program. You can implement using C program. You can write program and do that operations also. Okay, well, today we just understood what is array, what is it used for, when it is used for. When? Because when a large amount of elements are there, when you can use to store for uh, to store in arrays. Okay, that is the advantages of using arrays. Then how it is denoted, how it is initialized, how it is denoted, each element is how it is denoted by what subscript we call subscript notations, then how it is represented in the memory, then what are the operations we can perform on a single dimensional array. So this information we gathered today, we understood. Next coming session we are going to continue on two-dimensional array. Okay, take care, stay blessed, God bless you.